Hi there, my name is Cody Hosterman, and I'm the technical director here at Pure Storage for VMware Solutions Engineering. I'm responsible for all of our VMware integrations and best practices and reference architectures, really wherever VMware and Pure uh, connect from a technical perspective, myself and of course, my team. So today, what I'm going to be briefly talking about, and I'll show you some resources where you can get some more information afterwards, is demystifying Kubernetes and cloud native storage with VMware. And really, the specific focus, of course, for this session is not going to be on all of Kubernetes, right? I mean, that's a huge topic. We could spend all week talking about that. But the focus will be on the core storage portion of it, right? Where does Pure play with Kubernetes when it's deployed on top of VMware? What does that mean? And what is VMware offering? Because one of the things that's comes up over and over when we have these Kubernetes conversations with customers these days is a lot of the common questions we have around storage in general, right? How do I back it up? How do I restore it? How do I operate around dev test? How do I create copies? How do I protect it? How do I replicate it? What's disaster recovery look like? What does migration look like? Should I put it on top of VMware? Should I put it on top of bare metal? Should I put it in AWS? Right, where should these goes? Where should these go? Where should I put it? Right? How should I connect them? How should I deploy them? Right? These common questions are out there. And a significant part of this conversation is that there's a lot of VMware out there. A lot. Most of our customers are running VMware in some way or some fashion. And so there's some interest, a lot of interest rather, on deploying Kubernetes offerings on top of VMware, right? VMware for many years, VMworld specifically, was the de facto storage conference. And there's a lot of ecosystem built around the storage, around backup and recovery, and DR around virtualization from VMware. And in many reasons, because of what VMware built, they built a great ecosystem and a great product. And so, how do we leverage that? How do we leverage all the great technology from VMware, vMotion, HA, et cetera, et cetera, et cetera, but then also offer up the ability to modernize applications through Kubernetes? Because what we're seeing is not necessarily even every customer is refactoring their applications to deploy via containers, but even the off-the-shelf stuff that they're buying from software vendors are being containerized. And so having at least some practice to deploy those makes a lot of sense. And VMs aren't going away. There's millions and millions of them out there, and there will be VMs for a while. And so the ability to operate both in a consistent manner makes some sense, right? So these traditional questions around infrastructure management aren't going away just because we're moving to containers from virtual machines. The question sometimes changes. The answer is sometimes different, but in the end, these questions linger. And so VMware's been doing a lot around this, not just offering up Kubernetes, but offering their own managed service around it. And there's a couple pieces to really think about when talking about managed Kubernetes on top of VMware. There's three probably pieces of information or titles or applications or products or whatever you want to call it to keep in mind. There's Tanzu. Tanzu is a management and control plane for Kubernetes, for importing existing Kubernetes environments, deploying new ones through Tanzu Kubernetes Grid, et cetera, across not only on-premises VMware, but also in the public cloud. And then there's I don't want to say next step, but then also a complementary offering around vSphere with Kubernetes, which is taking a lot of the Kubernetes pieces and the infrastructure layers and tightly integrating it into the vSphere hypervisor to make containers and the applications running on top of them, the namespaces and pods, first-class objects inside of ESX and vCenter, much like your virtual machines of today. And then, of course, how storage is managed and provisioned underneath that. And this is one of the great things around all these different offerings, whether they be through Tanzu or vSphere with Kubernetes or both, is that VMware offers a driver called Cloud Native Storage that allows you to leverage your existing storage infrastructure up into those Kubernetes environments. And that's what we're going to be focusing on in this quick session, is what that is. So what is it? Well, in the orchestrated Kubernetes or orchestrated containers world, more accurately, there was certainly a need for standardization around storage management. And this manifested itself in what's called CSI, Container Storage Interface. And this is a specification for a driver that a vendor can build to integrate storage provisioning into a container orchestration platform. Most commonly, that's going to be Kubernetes. And so VMware introduced their own CSI driver, very uniquely named Cloud Native Storage. And this was introduced natively inside of vSphere in 6.7 Update 3. And fundamentally, what a CSI driver does is it takes some underlying storage layer, whatever that might be, and converts it and provisions it into something that a container or a Kubernetes pod, for instance, can understand and use. So in the case of VMware, what is that? Well, that's taking storage presented via data stores, NFS data stores, vSAN data stores, VMFS data stores, vVol data stores, and provisioning them up to a Kubernetes environment running on top of VMware, right? So using all that storage ecosystem, integration and tools, and the value of the underlying platform that you paid for, but provisioning it up into the Kubernetes environment running on top of VMware. And that's what cloud native storage is at a very high level. It's VMware's integrated CSI driver. Now, what does VMware use to abstract the storage? Do you want your Kubernetes admin, or more likely your engineer or developer that's provisioning applications through Kubernetes, to understand the bits and pieces of the storage? No, you want to simplify it as much as you can. And we've certainly done that in Pure in general, but you can even simplify it more around SLAs, right? This one's replicated, that one's not. And so what is that provision from? What does CSI provision from? What if I have 30 data stores? Which one does it choose? What if I want this feature? How does that get done? Well, this is done through policy-based provisioning, sometimes called SPBM, storage policy-based provisioning. Using storage policies, Kubernetes deployments and applications running in pods can deploy their own capacity, their own storage from those data stores by specifying a policy. And this is particularly important around something like Pure Storage virtual volumes, is that storage does not need to be pre-provisioned. When you provision a new virtual disk, a new piece of storage from a vVol data store, it gets automatically created and connected where it needs to be connected. And it gets provisioned according to the features that you specify in that particular policy. And this really simplifies it up the stack, not only for the VMware administrator, but also for that user of Kubernetes, the person deploying that application. And so when you're using the vSphere client, for instance, to provision storage, you choose a policy, and then that policy will say, oh, hey, these data stores are compatible with the features inside of that policy, and then you choose one. And then it automatically creates and provisions and configures the storage as needed. And it's not just about day 0, it's also about day 2. If someone goes and reconfigures it or changes the underlying configuration, VMware will know about it and alert inside of vSphere, saying it's either compliant or non-compliant. So you know that a change has occurred. And of course, you can also reapply policies to reconfigure them on the fly. And inside of CSI, it uses something called storage classes. A storage class is a pool of storage of some related thing, whether it be a failure domain, features, storage type, and you can define them as you want to. Inside of CSI, you define a storage class with VMware to map to a storage policy. So if you have a storage policy that simply says, hey, I want anything under this policy to provision from Pure vVols, that would map to a storage class that can be chosen when deploying new storage to a new pod or a new container that needs persistent storage layer. Hey, I need this to be replicated. Well, then choose a replication type policy that maps to that storage class. So you enable that policy for that end user of Kubernetes by instantiating a storage class within something like Kubernetes. Now, what actually gets provisioned? Well, when you provision a new virtual disk, well, traditionally when you did that, what did you have to do? Well, you had to pick a VM and then go and create and add a new virtual disk to it. But this required having a VM. I may not know what VM I want to provision, or where is this container actually running? Is it even in a VM? What if I don't need that storage quite yet, but I want to provision it? Or I don't need it anymore, but I don't want to delete it because I'm going to be reusing it in a bit. And so this requires a virtual disk to live outside of a virtual machine. VMware introduced something called first-class disks, sometimes called improved virtual disks, To do just that, you can create virtual disk independently of a virtual machine and then add it to a VM and remove it. First-class disks is what VMware's cloud-native storage CSI driver uses to provision and manage storage. By choosing a policy and a new first-class disk upon creation, that disk gets created and configured and not yet assigned to a virtual machine or a container until it's needed. So you can deploy what's called a persistent volume to create a new virtual disk, and that gets claimed by a Kubernetes pod when it gets instantiated. A persistent volume claim, as often is called, maps to a first-class disk. Now, on the FlashArray, especially with vVols, this is particularly interesting because a vVol type virtual disk is not only a first-class object on the array, every disk is its own volume, and then you can use our features and our reporting on volumes to manage it. But of course, now it's also a specific object inside of the vCenter API. It is a disk that can be independently managed. And this is extremely useful in Kubernetes world where VMs may or may not be in use. They may or may not exist, but you do need to provision storage or have persistent data that outlives those particular virtual machines and containers. And so the vVol connection, because things are configured and deployed on demand, and our granular objects on the array itself allows for this use case and some interesting other ones. Because in the end, on the FlashArray, a vVol is a volume. It's just a volume with whatever file system puts on it. In the case of a persistent volume claim, that's XFS, ext4, whatever that happens to be. And we don't block you from moving that volume. So you can move in a persistent volume claim from some other implementation or move it out. And using our CSI driver, Pure Service Orchestrator, that can be orchestrated in a different environment, public cloud using Cloud Block Store, on premises outside of VMware using PSO, and moved in and out of Kubernetes distributions on top of VMware, leveraging VMware's CSI driver, Cloud Native Storage. And so it's not necessarily an or, it can be an and. And we're working with VMware to expand that and use case directly inside of vSphere. So keep an eye on enhancements around VMware support of CSI. If you'd like some more information, a great place to follow and find out new blogs, new KVs, new demos and videos and new releases, go to the What's New with VMware and Pure Storage page on our support site. I've written a deep dive blog post on what first-class disks are, especially when they come to vVols. You can check that out there. And also more information on our CSI driver, Pure Service Orchestrator, which you can check out on GitHub. And of course, use the QR codes to immediately go to those URLs right now. Thanks a lot. I appreciate your time.